Okay, let's get started. So just to let you know, I'm also recording the section, so in case you want to play it afterwards, or if you find useful, you can share it with your colleagues. So for this 45 minutes, I'm going to show you how to use Leafmap and also WhiteboxTools to do geospatial analysis and some watershed analysis. And so if you go to the website leafmap.org, you'll be able to find all the documentation. So Leafmap was a Python package mostly for doing data visualization. I started it about 2 years ago, and but I've added a lot of features into that. I also have some other open source packages. If you're interested, you can click the upper right corner here, go to GitHub, and then on the upper left corner here, if you go to OpenGOS, so those are some of the open source packages that I created, and some also data catalogs. So Leafmap was kind of spin-off from Gmap. So for those of you using Google Search Engine, so I developed the Gmap for working with Google Search Engine using Python. And then some users wanted to use outside Google Search Engine, but they also want to use load interactivity of the Gmap package. And that's why I created Leafmap. Although it's pretty new, but it's being used by NASA, by Microsoft Planet Computer, and some other cloud pro, also AWS. And so today I'm going to show you how to get started. It's pretty easy, and I'm going to show you step by step how you can follow me, and then you can run the code. You can see the output. You can change things pretty easily. So let me go back to the repository. If you go to Leafmap and then click leafmap.org, on the left side here, click workshops, and there's ICRW 2023. So this is the notebook that I actually just created yesterday or on Saturday. So thank you, Mark, for the invitation and the opportunity for here to present. But I don't have a lot of text in here, mostly just a lot of code blocks, but it's pretty easy and self-explanatory. So I'm going to show you how you can do that. For those of you who are already Python users, you want to install packages on your computer, you can do that. But I would recommend that you just click open in Google Colab. You can right click and then open the link in new tab. So this one you can run through that using Google Colab. So Google Colab basically is a cloud computing environment that allows you to run code, basically Python interactively. You can also run R if you want to. So for Python, and upper right corner here, you just click sign in. You need to have a Gmail account, and then you can just run through step by step. I'm going to show you later. So here, if you hover your mouse on this code block, let me zoom in a little bit. So for this tutorial, basically you need the Leafmap and also GeoPandas. They've already covered GeoPandas, and Mark covered GeoPandas earlier. And you also need Leafmap. So all you need to do is just on your keyboard, you can remove the hashtag at the beginning, just remove it, or you can just Control/. You should be able to remove the hashtag, and then you can just on the left side here, just click this one, just run it. Then you should be able to every code block is just on the left side, just click run. You should be able to run every code block. Any questions? Can you all access this one, log into your account, and then run through it? So it should be pretty straightforward. I'm not logging into my account because I'm using the guest account in Chrome. And so, and for the remaining of the section, I'm just going to use my local Jupyter notebook because the user experience is much better. But you should be able to run step by step, just like when I'm introducing. You can just click the play icon, and then you can run, and then come to here, you can click run. So for here, I'm going to, because I already installed all the packages, and I'm going to just show you here on my computer, just Shift Control, you will just run the code block. So basically import the library, but basically you need to install all the packages first, and it only takes, I think, a couple seconds. And once you install, then you can go to the next block. So here, first I'm going to import the libraries. On the left side here, this shows you the table content. And then I'm going to show you how you can create a map. You see, pretty simple and easy. So this is the interactive map. You can zoom in, you can zoom out if you want. However, you can move your mouse. You can zoom in and zoom out. So here, show you how you can create an interactive map. So leafmap.map, and then you can specify the center basically the latitude, the longitude, the zoom level, and also the height, basically the map. If you want a smaller one, you can just change to maybe, for example, 400 pixel, and then shift enter again. You should be able to create a smaller one. So it's pretty easy. And the next line here, M, basically is just variable pointing to the map in the memory. So you are displaying the map on the Zuby notebook. So you can create any location like. You can, for example, change the, by the way, so it's latitude, longitude, okay? Some other software use longitude, latitude, so sometimes it can be a little bit confusing, but this is latitude, longitude. So if you change, for example, to here, 140 and 100, then you probably go to Asia countries, right? So you can change it. Also, you can change the zoom level. Very easy to use. So next, how about XM base map, right? There are tons of base map on the internet, and Leafmap makes it really easy. It's just like basically a name, and then so I'm gonna show you here, right? I'm going to add open topo map. I'm going to also add the USGS 3D 3D elevation, and also USGS hydrography, right? So those are all the web services, right? You can access from the internet. Behind the scene is just a URL. And so Leafmap makes it really easy because you don't have to go online to find the URL. And also, if you have your mouse to the upper right corner, so there's actually most of the interactive functionality of Leafmap. Actually, you don't have to do coding. I already do the coding behind the scenes, so now you can just use it. So if you want, for example, you can click this sandwich icon. It's going to pop up showing all the data layers. So this is more like in the desktop GIS, you can turn the layer on and off. So for example, oops, right, I can turn them all off. I can turn just OpenStreetMap, Open Topo Map, right? You can turn it on. On the right here, you can also change the opacity of the data layer. So for example, US hydrography. And also you can see that, right? And the US 3D elevation is just in the US here. It's not available in other location. But this just show you how easy to create a map, and then you can add there. You can change things around if you want to. There are a lot of other buttons here where you don't have time to go through it, but you're welcome to try it out. So each button basically have some functionality allow you to interact the map, pull some data. You can also, for example, here, for those of you like want to do some, for example, cloud computing. There are tons of data on AWS, Google Earth Engine, Microsoft Printed Computer. So here I can just click the button, and so this is kind of the 3 lines icon. And then from here I can, for example, AWS, Microsoft, whatever, and I can come to zoom in to any location you like. So for example, I want to find some data in San Francisco, right? I can zoom in, and I can simply draw a rectangle somewhere, anywhere you like. Right, and then just click search. You can also specify the date if you want. So you're going to search all the data in the AWS in the Sentinel-2, the entire data catalog, and it's going to tell you like how many intersecting with your area, and then you can select, for example, which tile within this area, and then you can just select display. So also the pop-up here shows you all the attributes of the data. This might take some time. It depends on where you are looking at. So on the left side here, now you see the map, right? The Sentinel-2 imagery, Landscape or any others. So nowadays, most of the data in the cloud. This makes it easy. They can pull data from the cloud without having to download anything. And of course, I can change, for example, bank combination. I can change it to, how about red, green, and then, for example, blue, and just display it. So keep in mind, this is like terabyte, maybe petabyte of data in the cloud. So you don't have to download, you just put it in anywhere you like. You can do simple visualization, and then you can do, for example, just like this one, you can turn the layer on and off, right? You can turn off the footprint, turn off this. Let me remove the polygon, and then here, I can change the opacity, just like this. You can zoom in and you can zoom out. At least looks pretty simple, but behind the scenes, like thousands of lines of code actually to be able to synchronize everything and then make it connect all the dots and then display. So if you're interested, you can try it out to find some data you like. And so next, I'm gonna show you here more data. For example, base map. So here you can also add laser. For example, I can add the NLCD. So Leafmap already have a lot of built-in base map. So all you need is just a keyword, basically the name. Hybrid means the Google satellite base map, NLCD 2019, you have 2016, 2011, something like that. If you're really lazy, you can just click this one here, the first icon, the base map, and this one here is like have all the base maps. So the name come from here. So if I want like other base map, you can simply just change here. For example, Google Terrain. See, you're gonna change instantly, and or NLCD 2016, 2013. It's all embedded in there. So if you don't need it, you can just close it. Yes. 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 Oh, it's all web map services. Yes. Yeah. So right now, if you don't hide it, you can command it. I think I also have some function that you can actually hide it. So the legend is linked with the data layer. If you let me see here, I'm not sure if I have that function. So here, the layer name. So if you link that with whatever layer name is, when you turn the layer off, it should turn it off. So right now it's not linked yet. So if I turn this one 2019 off, it's not yet, but I can add this one layer name equal to the same one of this, and I believe it should turn it off. And now they come to here. Oops. There might be a bug. Being some of the Gmap, I actually did it, but it's a good question. I can certainly, if you want, you can also I think m.controls. I think the easy way is to recreate it, because most of the things is very quick. So use m.controls. So the control says everything about on the map. So if you want to replace that, I can say m control equal to m.controls, and then I think it's the square brackets. I'm not sure if it works or not, like this. So basically, to the negative ones, if you remove the last one, I can continue to remove more. It's going to take out some other tools. So this is everything is based on built on top of IPy widget and IPy leaflet. Basically, everything is a widget, so you can put things in, you can remove it, and it's also interactive. I will show you more examples later. So this is using a built-in base map, but there are also tons of other base maps around the internet. So if you have the HTTP URL, you can directly pass in the URL. So here I add the Esri wall imagery. I also have this one. Is basically the same thing. So this is the example I showed you earlier. Under the hood is actually calling this web service URL and then add it to the map. But what I'm saying is, if you have some other base map that's not built in here, you just need a URL. It can be WMS, it can be XYZ. So it supports most of those web map services. And then you can add a legend. So it's pretty simple, just one line of code, then you can do that. Okay, so that's the basic about creating a map, and then add some base map, and then play around with it. So next, I'm going to show you how you can actually get some data. So how you can actually download some data for your area, and then you can visualize that. You can do some analysis if you want to. So this is the function that you can get NHD basins. So this is actually the function that I just added over the weekend. Because I follow Mark's example, I'm going to show the same watershed using the same, basically the com ID, and then leafmap.get NHD basins is going to return a geodata frame. So this is going to take some time to, under the hood is using a Pi NHD, but it's Rabbit, so it's easier, just one line. And once you have that GDF, so you can do this, can look at this code block here, pretty much similar to what we did earlier. We create a map, and then we add the geodata frame, and then you can give a layer name, and then I can also I add the layer manager, but I think the layer manager doesn't work very well on Google Colab, but you can ignore that. So basically, I can add this one right now. You can see the basin here. So this is a vector data, so it's a geodata frame. I just add GDF, and then it's add to the map. So it's very simple. Once you have the vector, you can also save it to a computer. So for example, GDF.file, so you can save as a GeoJSON. You can also save as a SWAP file or any vector data format you like. Because under the hood is using GeoPandas, so you support all kind of vector data format. On the left side here, I can show you like once you save the data, it's going to on your computer. On Google Colab, it will be on the left side, the sidebar here. If you click this icon, I'm not logged in, so I don't see anything, but you should see the file after you execute the code block. You should see the file on the left side. So with the watershed boundary, now we can get some DEM, right? So similarly, get 3-step DEM and then passing the geodata frame from the previous step. And you can specify the resolution, 30 meter, 90 meter, and then the output, okay? Output file name, you can also specify coordinate system. So the DST CIS, I set this one 3857. So this is basically the web marketer. Basically, most of Google Map and the web maps, they're all using this 3857. I also tried like 5070, like Elbos, but you want to see the pixel, like it's not really horizontal and vertical because of projection. So this one looks a little better. And if you run this one the first time, it's going to take some time to download the data. It might take 10-20 seconds. And once you grab the data, so the next step will be just to load the data into the interactive map. So just add raster and then passing the input file name. You can also specify a palette and take a look at this. Very simple. So this map is also interactive. You can zoom in, you can see that. One thing to note that on Google Colab, it looks like the image looks a little bit pixelated. I'm not sure if any of you run the code. It doesn't look as well as on my screen here. So there's a bit of a bug for Google Colab, but you can see now I have the DM and I can turn it off. I also have the basin, the boundary, and similarly, I can turn it on off. So everything is interactive, and this makes things so much easier rather than print out the thumbnail is static. Sometimes you want to play, you want to zoom in and zoom out, and this can help you. And it's just one line, add raster. You can add any raster, so it doesn't have to do the data. You can also add raster from the cloud. You don't have to download data. So add code layer. If you want, there are tons of functions of the map. And so let me create a new block here just to show you. Right, you just type m dot and then hit tab on your keyboard. You should be able to see a lot of functions that allow you to add the data, to visual the data. We don't have time to go through all of this, but you can explore it if you want to. We only cover the most essential: visualizing vector data, visualizing raster data, and the data can be hosted on anywhere. You can be on your computer or it can be in the cloud. So once you have the data, you can look at the image metadata. So for example, we download the DEM. You can look at just the image metadata. You can see all the information. So this is similar to if you're using desktop GIS. You just open the property and then look at all the attribute. Everything here is also accessible through the code. And the reason I want to add this because I want to add a color bar to the map so that I can show you the elevation, the value range of the elevation, right? So now if you look at the band, right? So the minimum is 60, the maximum is 15, 24, right? And then I can just call this function add color map. And then so the CMap is terrain, the minimum is 60, 1500. I think you can both double quotes or non or just value, either one should be fine. And now if you scroll down here, right at the bottom, you can add the color bar to just show you the value. So that means easier to interpret what's the high elevation, low elevation. And again, everything pretty much is just one line of code. Once we have the DEM, next we can do some analysis. So let me show you how we can do some simple watershed analysis, hydrological analysis. There are tons of tools. So it is using the WhiteboxTools. I think at the beginning of the notebooks, I put some links in here, Leafmap, also WhiteboxTools, and also the manual. So I'd like to give a shout out to the Whitebox developer, Dr. John Lindsay at the University of Guelph in Canada. So he is the one that developed the WhiteboxTools. It originally is just a command line program. Basically, it's a exe executable, and then you can just download and run on any computer, Windows, Mac, Linux. And I built on top of this one to provide an interface. So if you want, you can go to the OpenGOS. You can take a look at the example here. So I have built in the Python, Jupyter, also Whitebox R. So if you're an R user, you can also use Whitebox R. It has over 500 tools from all the GIS, remote sensing, and also hydrological tools, and also Whitebox ArcGIS. So if you're an ArcGIS user, you can just download this one. You can run it, edit one to your ArcGIS project, the catalog, and then you should be able to access all the tools. Nice thing about this is all open source. So if you want to see the source code, make changes, you can do that. And there are tons of tools in here. If you've never used it, give it a try. You might love a lot of tools you won't be able to find in ArcGIS. There are a lot of tools that are very unique about hydrology and also LiDAR data analysis. So depends on environment that you're using, ArcGIS, R, Python, you name it. So I developed some of those for Python, Jupyter, ArcGIS, and also R. So for different platforms. There's also a QGIS plugin. I didn't develop it, but you can Google online, you should be able to find it if you use QGIS. So next, let me come back to here. So if you want to use Whitebox, it's pretty easy. So Leafmap.WhiteboxTools, and then just assign it to the variable. So when you are running this for the first time, it's going to download the executable from the internet. It might take a couple seconds. And once it's downloaded, they can check the version. So right now it's version 2.3. And this is the one I was talking about, like interface. So I also have the Whitebox GUI. This is pretty much similar to the ArcGIS toolbox, right? You have a toolbox, and you can have a bunch of tools in here. If you see at the bottom here, 518 tools. There are tons of tools. So if there's any tool you like, you can click, and you can go to the help. You can go to the help documentation. You can also look at the source code. So there are a lot of tools available that can allow you to do a lot of analysis, and it's really, really fast, much faster than ArcPy. If you compare it, but I'm not going to use the tool, the interface here. You can click select file, you can input, output, and you can specify the parameters. But I have all the code blocks beneath, so that it's reproducible. If I'm just clicking a button, sometimes it's hard to follow. But if you're just executing the code blocks, you will get exactly the same result like mine. So after you create the Whitebox tools, the first step will be to set the working directory, and so you can use basically where your data on your computer. So basically the file pass to your directory. Right now I'm just using my working directory. So on the left side here, this is my working directory, but it can be any absolute path you want to do. So next, let's do some analysis, right? So once you get a DM, one of the first steps, usually you need to do some pre-processing. So in this case, we're going to run the tool called feature preserve smoothing. Again, similar to the leaf map that I showed you earlier, if you just type WBT dot and then hit tab, you want to access to all the tools. So for those of you that use ArcPy, this is pretty much similar, but it's using open source, and it's very compact. So it's only like 20-30 megabytes compared to ArcGIS that you have like gigabyte of installation. And also, this is running on the internet, right? You just need a browser. You don't need to install anything on a computer. So sometimes you might be questioning, like, oh, I can do this, everything in ArcGIS. Yeah, but this is more reproducible. This is much more easier and much more compact. And then you can deploy on the web. Everyone can have access to all the tools. So the first one here, I'm going to run this one. It's called feature smoothing, preserve smoothing. So you can also use some median filter, mean filter, all kind of filter you want. So input, output, the filter, basically the window size when you're doing the smoothing, right? Pretty simple. And once I have the data, pretty much similar to what we did earlier, right? We create a map, we add the smooth DM, we also add the watershed boundary, and also the add layer manager. If you're on Google Colab, skip the add layer manager. It probably doesn't work right now. Oops. And so look at this, right? So now you have the smooth DM. You also have the watershed boundary. And this is where we get started. Once we have the smooth DM, then we can do all kind of hydrological analysis. So the first one here, I'm going to show you what is a watershed, a hillshed, right? So the input, the output, and also some of the parameters, you can just run it. So we have this one saved to the computer. And the next step will be to add the hillshed to the map, right? And then you have a layer name, and also another line here, m dot layers -1 dot opacity. Basically the layer we just added, so it's -1, the sequence. And then I also changed the opacity to 60%. And if I run it now, come back to here, and you can zoom in to see the effects. If you're on Google Colab, probably it doesn't look as good as this, but at least right now you can see pretty good, right? It's interactive, so it's a notebook. And if you want, you can change the opacity. Right, so from 1% to 100%, and this looks better when you're using LiDAR. Right now it's using a 30 meter. You see a lot of artifacts in here. You can smooth the DM a little bit more if you want, but at least this is what if you can do some simple visualization. This is something you can do. Okay, with the hue set, now we can do some real hydrological analysis, right? So one of the first step that if you do hydrological analysis to fill the depressions, this one of the very common steps. And so in WhiteboxTools, there's one called find no flow cells. So basically, there's some sinks, some depression that there's no flow direction. So it's just going to find basically the cell that doesn't flow anywhere. So it's basically accumulating water. And well, the input will be the DM we already smooth, and this is the output. So again, run this really quick, and then we add the raster back to the DM. So take a look at this one here. You probably need to zoom in to see where are those pixels. See, so those are all the pixels on the DM. Basically, they all represent surface depressions where water gets stuck. If right now you're running hydrological modeling on this one, this is the DM that's going to cause problem, and that's why we usually fill the DM. The reason I run this one is to show you based on the elevation values, like which one is basically lower than 8 neighborhoods, and those black points is where those pixels are. So once we have an idea about how many of those pixels, then we can start filling the depression. So this is where we create a so-called depression list DM, also called hydrologically corrected DM, that basically without the depression. So you fill everything. And so in the depression filling, there are different algorithms. So in WhiteboxTools, it has, I think, 4 different algorithms. So the common one, we just fill the depression. So you just fill everything. But sometimes you can create a lot of artifacts, especially have rows and others. Usually would recommend right now using the so-called breaching depression. So that one has minimum impact on the DM. So it's breaching rather than fill the DM. Otherwise, you can create some very large artificial like reservoir it's not supposed to have. So you can fill the DM. Oops. So let me rerun it. Over. Yeah, don't worry if it sometimes it's broken. You just rerun it. It should work just fine. Let me see here. Video output. Yeah, I hope it works. Is it the internet? Oh no, it should work. Okay, let's just wait for a couple seconds. Let me remove those. Yeah, the beauty of coding is that everything is reproducible. So you can fix it every time you. I think I need to fix this one. Okay, hopefully this is the last time. And so depression filling, depression breaching. So I'm going to use the depression breaching, and then you can run the no flow cells again. So basically to verify that once you fill the depression or breach the depression, there are no more depressions on the DM. And then I add this one to the map again. So now if I zoom in, so if I turn off the no flow cells, right, this is before we fill the DM. And now you see all the depressions have been filled, have been gone. So now this is a hydrologically corrected DM that without depression. So when you do the modeling, extract the stream network, you're going to get continuous. Otherwise, you're going to have all kind of problems, non-continuous. Okay, so this is right now basically the pre-processing steps, right? We have filled the DM. Now we are ready to do some watershed analysis. So usually the first step we want to do is basically create the flow directions, basically the 8 neighborhood. This is D8, but WhiteboxTools also has other It has other depression algorithm, and I would recommend if you go to the user menu, and on the left side here, I can show you quickly hydrological analysis. So see all the tools available here. I think there's maybe 50, 60 tools available, a whole lot more than what ArcGIS provides. And also there's a specific one called stream network analysis. And so today I'm going to showcase maybe 10 tools they were using, but there are a lot more that you can explore to do a lot more advanced hydrological analysis. So let me go back to here. So the first step is delineate the depression, and the next one is the accumulation. So we're going to figure out this watershed, how much water is contributing, floating into each pixel, right? So look at this, very quick, right? It takes less than 1 second. Now you get the flow accumulation. It's probably total black. If you zoom, you probably need to zoom in. You see the red line pixel. So this is actually where the flow accumulation. So the red line makes it higher accumulation. So it's a higher value. Basically, you upstream how many pixels floating water into this one. And so with this flow accumulation, then we can extract streams, because clearly if you see the pattern, right, we want to extract those bright color because those represent the main stem and also the stream. You need to set a threshold to figure out how, basically the lower the threshold, the more stream network you want to extract. The higher the value of the threshold, you want to probably extract just the major streams. And if you want, you can certainly Leafmap also has some tools allow you to inspect the pixel values. So right now I'm zooming here. If I click upper right corner, and there's a tool here like this eye identifier. I can click it, and so from here I can hover my mouse. I can click on the pixel. You should be able to see the pixel value here, the location, the latitude and longitude. So Leafmap allow you to interactively explore the data, get the pixel value or get the spectral signature if you want to. So you can zoom in, for example, look at this one, right? So this is probably, this direction is the downstream, and this is, oops, moving to, so again, you can zoom in to the upstream here. Basically, you need to define a pixel value, and if there's specific pixel value you like, if you already know, you can just use something you like. If there's no, right? So if you go way upstream, the value is going to be a little bit smaller. So once you have this, then you can extract the stream network. So let me show you here. By the way, so all the maps are duplicating. It's basically the same view. I just use the map. I just continue to add data layers, but you can create a new map if you want. So the reason I create this new one, display this, because I don't want to scroll up, but you can just have one map with all the data layers if you want to. So now, once we have the flow accumulation, right, then we can extract the stream network. So the input, the output, and also the threshold. So the 5,000, basically 5,000 pixels contributing to this one, then you extract the stream network. Let me show you extract this. Oops. Not sure why, but I don't use Mac computer. So but when I travel, I use Mac computer. Most of the time I use Linux. So everything works fine. I don't expect it to die so frequently. So hopefully you get the stream network, and probably if you run on Google Colab, is I think a little bit more smooth. It should not crash this often. So now, okay, I forgot to extract, to add this data layer. So add the stream, and so let me turn all the data layer off just to show you the watershed, the stream, and the smooth DM. You might need to zoom in a little bit to see that it's all black color. But if you zoom in, you should be able to see that, right? So we get a flow accumulation, we set a threshold. Now we have the stream network, pretty easy. And of course, I mean, we already have NSD while we're doing that. That's not the point. You can replace with any data you like, LiDAR data or other data. I'm just showing the overall the workflow, right? So now we have this in raster format, and you can also have some other hydrological analysis too. For example, calculate the distance to outlet, right? So the outlet, you probably know, is at the bottom on the northwest corner, somewhere here, right? You can probably, let me show you here, just to show you where it looks like. It's better to show the satellite imagery. So I'm going to click here and show, oops. We click the hybrid and zoom in a little bit here. You see, is this basically this outlet is here in this river, and so we have the streams. And if you see the Google, let me switch back to the Google, the OpenStreetMap. Yeah, there's some bugs. I supposed to switch back. Terrain, and then Watershed. Also, we have the let me calculate the distance to outlet just to show you what it looks like. So that, I'm sorry. I wish we had a good Linux laptop that I can use. Anyway, so if I run this one again, you should have the distance to outlet. Basically, every pixel is going to give you a value, like how far is it from your outlet. So how far is it from your watershed output points. And if I come back to here, it's probably a little bit difficult to see because it's all like dark color, but just show you the tools. And I think the next couple ones will be more interesting because you can extract the streams and then you can convert to vector. So this one here, the raster stream to vector. So basically take the raster that you created from the flow accumulation and then set a threshold, and then now we can convert this one to vector. And once you convert, this is a lot more than so convert to vector, and there right now the WhiteboxTools has a bug, so it lose the coordinate system, so it's gone. So I Leafmap, there's a function called vector set GIS. So if there's like no projection, you can specify, for example, CIS EPSG 3857. Now I run this one. Hopefully it doesn't die. Okay, so now we have the vector. This look much nicer because turn this one off. All right, so now you can overlay this vector. Let me turn off all the other data layers. All right, looks pretty good. You can also overlay on top of the satellite imagery. So this is like a couple lines of code, and then you can extract the stream network. You're welcome to replace with other watershed anywhere in the US, or you can just provide your own DEM anywhere around the globe. You should be able to do something like this, and it's pretty quick, right? If you rerun it, it's only like a couple seconds. So now we have the stream network. So next one can, if you have a DM, you want to delete a basin, of course, like NSD already have all of those, but that's not the point. So if you have a DM that you want to delete a basins based on the topology, then you can use the WBT.basins tool. And this is too crazy. Anyway, let me run. I think only a couple more code blocks, so we should be fine. So the basin basically is just based on like Dave introduced earlier, just the watershed, the reach of the division between different basins. And once you have that, let me see if it works here. So let me turn all the data layer off. In this case, you don't really see much because this is already in just one single large basin. So you most likely will get most of the pixels within a single basin. So if I look this one here, It's pretty dark. But if you zoom in, there are some like in on the edges have like brighter color, like very tiny basins. So those are mostly just artifacts. Let me turn this one off here again. But if you work on other area, you should be able to get some pretty nice basins. And next, we can also delineate the longest flow path. So this is like what Dave mentioned earlier, the main stem, right? If you want to just find the main stem of this watershed, you can use this function. And let me run all of them just to show you the results. I think it's easier. So the main stem basically is just the extract the stream network, the longest stream within the watershed, and then you can see the results. Let me show you here. So these are everything, all the results that at the end. But close. If you run off them, the map sometimes is going to be laggy because there's a lot of data layers in there. Let me turn off the flow accumulation, and so that you can see a little bit better. Okay, so here, if you see the longest stream, stream vector here, take a look at this one, right? So this is the longest stream of the watershed, and the tool can automatically extract that based on the raster that we created, and it's pretty good. And the last one I want to show you here, basically, you can also place arbitrary points anywhere on the network. Then you can delineate the upstream watershed. So this is especially if you're doing some like hydrological modeling using the USGS gas station, you want to figure out like where the water coming to here. Then this is the tool that I'm showing here. I can, based on anywhere here, I can, on the left side here, you can select a marker, and you can place a marker on the map. So you can select a point, and then you're going to use the point that I use, and then you're going to delineate the upstream. If you don't select a point, it's going to use the arbitrary location that I created, the point here. Basically, it's somewhere, oops, here. Right. So for example, I place a point in here, and then the program is going to use the point. You can also snap the pole point. So this is also very common in ArcGIS tools. That sometimes if the point is not exactly along the river, you can set a threshold like how far you want to snap the point to. So in that way, it's right on the river, so that you can get the upstream. Otherwise, you externally place a point somewhere else, you want to get nothing because there's no water contribute to that. So here, basically, just couple more tools, right? Snap the pole points. I create one, and then I snap it, and then lastly, delineate the watershed. So based on the point, it's going to get the upstream, and then I get the raster watershed, and then I convert to raster to vector. Pretty much that's it. So if you zoom out here a little bit, the yellow color is the vector one, right? But there's also the raster, right? And there's also the pole point that I use. This shows you exactly I place on the river is going to get all the upstream. Yeah, so right on time. So I hope you find it useful. The Mac computer is not working very well today. I haven't tested it before I come here. I only tested it on my Linux computer, but at least you can have a notebook. You can run it on Google Colab. You can download this one to a computer, and then if you want, you can set up the environment on your computer to run that if you want to. Because Google Colab, I think the raster display is a little pixelated. It's not very good, but yeah. So that's all I have. And any questions? Yes. Mm-hmm. Uh-huh. Mm-hmm. 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 Yeah, good question. That's exactly what I mentioned earlier. Bridge the depressions. If you just fill the depressions, all the cover and other stuff, you're going to get a big, like a small reservoir artificial, but it's not true. So the bridge depression actually is going to minimize the impact on the DM. So you're going to bridge, basically have a bridge crossing that. So they basically they make the DM elevation a little bit lower so that the water can move slow. So yes. So the bridge depression, that's the one that usually recommend if you work on urban landscape or some other have rivers, roads. You don't want to fill the depression. You want to bridge it so that the water comes through and you don't modify the elevation, because otherwise, all the elevation can be fake because you fill the entire one. It never happened because there's a river coming through the under the bridge. Yeah. Any other questions? Okay, thank you very much, and hope to talk to you more in the next couple of days.